So condition for tangency to ellipse. So basically what we are trying to figure out is, given a line and an ellipse, when will the line be a tangent to the ellipse? Now in standard form we know the equation of the ellipse. So x square by a square plus y square by b square is equal to 1, where a is greater than b, and the line is given to us in the form of y is equal to mx plus c. Okay, so now let's understand. The ellipse is like this. Let's say what we want to figure is what condition has to be satisfied for it to be a tangent. That's all. The common points between these two we can find out by solving both of the above, and for that we substitute y in the first one. So x square by a square plus, now instead of writing y square we do the substitution, mx plus c square by b square is equal to 1. Now let's just keep simplifying it. M square x square plus 2mx c plus c square by b square is equal to 1. Let's split it off. X square by a square plus m square x square by b square plus 2mxc by b square plus c square by b square equal to 1. Or we can bring that 1 to this side, equal to 0. Now here you have x square, here you have x square. So let's take it together. So 1 by a square plus m square by b square x square plus 2mc by b square x plus c square by b square minus 1 equal to 0. So what we have arrived at is a quadratic equation of the ellipse and the line combined. So that means since it is a quadratic equation, the line passes through the ellipse at 2 points, okay, at this point and this point. Now it would be a tangent only if, now it doesn't matter whether the line goes like this or like this. Here also you have 2 points. So for it to be a tangent, this has to pass through only 1 point, right? Something like this. Now this is possible only if b square minus 4ac is equal to 0. If it is greater than 0, b square minus 4ac is greater than 0 means what? 2 solutions. That means 2 points of 2 places at which it cuts the ellipse. For y is equal to mx plus c to be a tangent, it should meet the ellipse at only 1 point, which implies that the roots of the quadratic equation should be equal. That means b square minus 4ac equal to 0. Now let's check out what is a, b and c. A is 1 by a square plus m square by b square. B is equal to, b is 2mc by b square, and c is c square minus c square by b square minus 1. Let's do the substitutions. B square minus 4ac, so 2 mc by b square the whole square minus 4 times 4ac. A is 1 by a square plus m square b square. C is c square. We can write it as c square minus b square by b square is equal to 0. So now let's keep simplifying it. 4m square c square by b4 minus 4 times b square plus a square m square by a square b square. C square minus b square by b square equal to 0. Now this 4 and 4 can be taken out as common and take it to the other side. It becomes 0. So mc square by m square c square by b4 minus, now let's multiply it, b square plus a square m square times c square minus b square by a square b4 equal to 0. M square c square by b4 minus b square c square minus b4 plus a square m square c square minus a square b square m square divided by a square b4 equal to 0. So now this becomes a square m square c square. If we take the LCM of this as well, minus b square c square minus b4 plus a square m square c square, it's a square b square m square divided by a square b4. Now this, when it goes to the other side, becomes 0. Now a square, by the way, because here there is minus, so this whole thing will change. So this will become minus and this will become plus, this will become minus, this will become plus. So a square, m square, c square, these two will get cancelled, and what we are left with is minus b square c square plus b4 plus a square b square m square equal to 0. Now let's divide this entire thing by b square. Okay, b square, b square, b square. So b square, b square, b square, b square, b square. So we are left with minus c square plus b square plus a square m square equal to 0. So we can take the c square to the other side, so it becomes plus. So c square is equal to b square plus a square m square. So this is the condition that has to be satisfied. So remember, when we are talking of for a line to be a tangent to an ellipse, ellipse is x square by a square plus y square by b square equal to 1 and mx plus c. So we have c here, b here, a here, right? So a, b and c, and we have to figure out slope. So if we can figure out the slope and evaluate this, if left hand side and right hand side are equal, that means it is a tangent. Now here, if you notice, we are not getting the point of contact, or the coordinates we are not getting. So to get the point of contact, we need to do a little bit more work. Now remember, we had this quadratic equation, 1 by a square plus m square by b square x square plus 2mc by b square x plus c square minus b square by b square equal to 0. Now we already know c square is equal to a square m square plus b square. So let's do the substitutions. Okay, now let's add these up. We get b square plus a square m square. This and this are equal. A square b square x square plus 2mc by b square x plus, now c square, again we can substitute a square m square minus b square, no, plus b square minus b square by b square equal to 0. Okay, so in place of this c square I have done the substitution of this. So this b square gets cancelled. This b square plus a square m square gets replaced by c square by a square x square. 1 by b square is common to all of them, plus 2mcx plus a square m square equal to 0. Now this would disappear when it goes to the other side. Now let's write it as c x by a the whole square, right? We can write this. Now we can write this also as a square am the whole square. Now what we require is something in the middle so that it becomes a complete square, a proper square. Now how do we do that? If we multiply these two, we'll get an idea of what to put. So cx by a times am, so aa, so mc, actually x we don't need to write, mc, 2 is there, 2 will come from the exponent part, so this will become 2mc. Now this can be written as cx by a plus am the whole square. Now we can verify it very quickly. C square x square by a square, 2 times cx by a times am, so aa gets cancelled, we are left with 2mc. Okay, now which means this implies that if the square is 0, that means this is also equal to 0, which means cx by a is equal to minus am, which implies x is equal to minus a square m by c. So we have got the value of x. Now let's figure out y. Y is equal to line, right, mx plus c. So x is, we already know, minus a square m by c plus the y-intercept c. So minus a square m square by c, we can take the LCM and add up this also. So what we get is minus c square minus a square m square by c. Now we know c square is a square m square plus b square minus a square m square. So this and this gets cancelled and we are left with b square by c. So the point of contact is going to be x comma y, that is x is minus a square m by c and b square by c, or we can also write it as minus a square m by c. Now b square can be written as c square minus a square m square by c. If you don't have b, then you can. use A and C itself. Now, we know the equation of the line is mx plus c. We have arrived at c square is equal to a square m square plus b square. The condition for the line to be a tangent. That means c would be equal to plus or minus square root of a square m square plus b square. Now, this gives us two solutions. And more importantly, y is equal to mx plus or minus a square m square plus b square are always tangents to the ellipse. And since it is plus or minus, that means there are always two tangents equidistant from the center of the ellipse, parallel to a given line. I think that's enough. Bye for now.